Hello, this is Math 2231 coming to you from the College of DuPage for summer 2020, and this is the conclusion of the lecture where we're reviewing second review of 4 and Dawn of Limits. So here is the section B of the project that you're doing. Again, I expect you to turn in all of these problems, even the ones that we're doing here. But these you should have the right answers for, and you're doing all of them. Last time we did A, this is B, next time we're going to do C, and then we will do D. And this deals with analytic geometry. I'm going to do 5 problems with you, number 1, D, number 3, number 4, D and E, and number 5, C, to give you a leg up on this material. So here is the problem 1D. You know what to do. Let's see how you did. This was the equation of the line that we wanted to be parallel to. So if we solve for y, the coefficient of the x will be the slope. So the slope of this line is 1/2. And we want to find a line that's parallel to that, and parallel lines have identical slopes. So the slope of the given line, the one we're trying to find, has a slope of 1/2, and it goes through the point 2, minus 5. So it is y minus the y coordinate is equal to the slope times x minus the x coordinate. And sometimes I will ask you to put that in slope-intercept form for full credit, and I did it here. And what I will get is y is equal to 1/2 x minus 6. Let's look at number 3. You're to find the center and radius of the circle that has that equation. You know what to do. Let's see how you did. Well, you're going to consider the x's, and you're going to complete the square on the x's, and that's going to give you x minus 3 whole squared. Now that means you had to add 9, but we put this other 9 on the other side, so that's going to be a minus 9 plus 9, and so that's going to be equal to 0 so far. But then we have to complete the square on the y. So here is y squared, and this is 10y, so that's going to be y plus 5 whole squared. And then what we're adding to both sides is 5 squared, or 25, so we get this. So this is the equation of the circle, and then we need to recognize that the center of the circle is going to be 3, minus 5, and the radius is going to be 5. Here's problem number 4. We're doing D. We've got 2 points, A and B, and you're finding the length of the segment AB. You know what to do. Let's see how you did. This is the distance formula. So you will say 5 minus a minus 7 is 12 squared, plus minus 12 minus 4 is minus 16 whole squared, and I'll take the square root of that using the distance formula. This is going to be 144, this is going to be 256, so that's going to be added together to get 400, and the square root of 400 is known to be 20. And here is problem 4E. Given those points, you want to find an equation of the perpendicular bisector of that segment. You know what to do. Let's see how you did. Alright, so you look at these and you determine that the slope of this line joining these 2 points, that's y minus y1, is over x minus x1. You can go different ways, but you will get that the slope of this line through those 2 points is minus 4 over 3. But we want to find the equation of the perpendicular bisector of that, so it has to be perpendicular to that slope. That means the slope of the perpendicular line is the negative reciprocal of that. That is 3 over 4. You also need to consider the midpoint. So we add these x coordinates together and divide by 2, and that says the midpoint of the x coordinates is minus 1. We add the y coordinates together, being mindful of the signs, and we get that, and divide by 2, and that's going to be minus 4. So the midpoint is minus 1, minus 4. So then we're going to have y minus the y coordinate is equal to the slope times x minus the x coordinate. And then if I ask you to simplify that, and I probably would, you have to do fractions, and you get that y is equal to 3 over 4x minus 13 over 4. Here's number 5. I promised to do number C with you, so you want to sketch this region. And I think I actually modified that a little bit. I wanted you to describe that region because of the way I'm picking it up, which I'm still going to tell you later. But anyway, we're doing number C, y is less than 1 minus 1 half x. So we're saying, what is that in the xy plane? You know what to do. Let's see how you do. Well, you see I have a strict inequality here. It is less than, not less than or equal to. So the line y equals 1 minus 1 half x is going to form the boundary of that. It's going to have an y-intercept of 1 and slope of minus 1 half, but I will show it as dotted because you see the boundary is not included because that is a strict inequality. So I will get this. And then I will pick a test point to see, is it the half plane underneath or is it the half plane above? Since this does not go through 0, 0, 0, 0 is an excellent test point. I'll test 0, 0. And if I put 0, 0 in here for both x and y, or 0 for x and 0 for y, I'll have 0 is indeed less than 1. That is true. So that means I'm going to shade the half plane containing my test point 0, 0, and so the graph will look like this. Note the line is indeed dotted. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. Take care of yourself and of each other. God bless.